How y'all doing? Welcome to class 116. We're going to start talking about circuits today. It's pretty closely related to the last topic we were talking about with voltage and potential difference. Um, First, we're going to start by just looking at a circuit using the simulation. So what I want you to do is open up the simulation here, and I want you to light a light bulb using only a battery, wires, and a light bulb. So let's check it out. Alright, so if you notice on the left-hand side, you have a bunch of materials you can use, like switches, light bulbs, resistors, all those good things. Let's just start with a light bulb, like I said, a battery, and connect the ends with wires. Just be careful when you connect the ends. If you look at the light bulb closely, there are two terminals. Each terminal has to touch each end of the battery using wires. So don't touch the two wires to the same end of the terminal. Alright, and there we go. We lit our light bulb up. So a couple little questions. What measures the strength of the battery? Oh, let's look at that. Most of you might know this already, but if I click on the battery, it looks like it's measured in volts. So that sounds familiar, right? Voltage. All right. How does the voltage of the battery affect the light bulb? Let's see. So if I turn the voltage down, if I turn it up, how is that affecting the light bulb? Hopefully you notice more voltage, brighter, less voltage, less bright. Probably something you already knew. So as voltage goes up, brighter. And then, as voltage goes down, it's dimmer. How does the voltage of the battery affect the electrons in the wire? So let's see. So there are the electrons moving around those little blue things. So if I move the voltage up, what's happening to the electrons? Seems like as voltage gets higher, the electrons move faster. So voltage up, electrons move faster. All right, now we're going to work a lot with circuits in this unit. That was just to kind of get you a visual of what's going on. That's a great simulation. We're going to come back to it a few times. But we're going to kind of put it to the side for now. But the idea I want you to have in your mind right now is how voltage from the battery makes the electrons move. They can move fast, they can move slow. Okay? What we call that movement of electrons is current. Right? That's where we're at now. So current is defined as the number of coulombs that pass a point in a certain number of seconds. Okay, from your reference table, this is our equation for current. Now, Q we've seen before. Q means charge, so delta Q is charge, measured in coulombs. And T is time, of course, measured in seconds. But I is brand new to us. I is what we use for current. Now, you might see it written as a lowercase I, but generally we use an uppercase I, and it's measured in units of amps, or amperes, which is abbreviated with the capital A. All right? So current measured in amperes. Why did we use an I? I'm not really sure. So let's try out that equation. Let's check out where it is on the equation sheet first. No, wrong one. Safari, where was that? I think it was, let's go back here. Let's just click on here, it'll come up. There we go. All right. So it looks like, hope I didn't, oh, I passed it. Not waves, oh, there it is. I equals delta Q over T under the electricity. I is right here, current. Q is charge, T is time. All right, so it's right there for you on your reference table. All right, so what is the current in a wire if one electron passes a given point each second? So we're looking for the current. Q is 1 electron, so 1.6 times 10 to the negative 19 coulombs. It's got to be in coulombs for this. T is 1 second. So I equals delta Q over T, 1.6. You don't have to worry about the sign on the charge. Times 10 to the negative 19 coulombs over 1 second. 1.6 times 10 to the negative 19 amps. So if 1 amp, so that's I, is going through a circuit, how many electrons pass a given point each second? Right, so this is actually a two-step problem already. So times 1 second. So we're looking for Q, and then we're going to convert Q to number of electrons. Okay. So I equals delta Q over T. 1 amp equals delta Q over 1 second. So delta Q is 1 coulomb. All right, well, how do we get now from coulombs to number of charges? If you recall, we did this a little ways back. 1 coulomb multiplied by, remember, 1 elementary charge is equal to 1.6 times 10 to the negative 19 coulombs. So 1 elementary charge over 1.6 times 10 to the negative 19 coulombs. Coulombs cancel. And let's see what we get in our calculator when we do that. So 1 divided by 1.6 times 10 to the negative 19. We get 6.25 times 10 to the 18. All right. Oh, what is the current through a wire if 240 coulombs passes through in 2 minutes? So make sure you convert time. 2 minutes, how many seconds is that? 120 seconds. So I equals 240 coulombs over 120 seconds, 2 amps. So this one, if 10 coulombs of charge is transferred through an electric circuit in 5 seconds, then what's the current? So I equals delta Q over T, 10 over 5. And we get 2 amps again. Number 6 is a long question, but it's really not that bad. So a 1.5 volt AAA cell supplies 750 milliamps of current through a flashlight for 5 minutes. A 1.5 volt cell supplies 750 milliamps of current through the same flashlight for 20 minutes. All right, so the AAA batteries are those little ones. The C's are like the big fat batteries. Compare to the total amount of charge transferred by the AAA through the bulb. The total charge transferred by the C cell through the bulb is what? Well, think about it this way. They both have the same amount of current. Okay, but the C is doing it longer. So is the C going to have more charge flowing through it? I think so. Let's just go through the math. So 750 milliamps for both of these. In both cases, I is equal to 0.5 or 75 amps. In both cases, all right? So let's do the 2 cases. First case we'll do is the C, all right? So for the C battery, I equals Q over T. All right, so I is 0.75 amps. Q's are unknown, and 5 minutes is, what is that, like 300 seconds? So if we cross multiply 0.75 times 300, we get 225. All right. Excuse me, that wasn't for the C, that was for the AAA. I'm sorry. Now check out the C. The C is very similar. I equals delta Q over T, except current is the same, Q is going to be different. The time is 20 minutes. That's 1200 seconds multiplied by 60. And if we cross multiply, we get 900 seconds, or 900 coulombs rather. So how much more charge does the C have? Well, let's see, how many times does 225 go into 900? If you divide the two, you get 4. 900 divided by 225 is 4. So it's 4 times as great. There are other ways to do that one using just like more symbolic math, but that's the longer, more proper way to do it. All right, so we have 2 spark questions, actually really similar to one we did earlier. So we have a current of 0.1235 amps. And we have, let's see, time of 5 seconds. How much charge are we looking for Q? So I equals delta Q over T, 0.00005 amps equals Q over T. We're going to cross multiply. 0.12345 times 5. We get 0.00025 coulombs is our charge. Now, how many electrons is that? Well, we have 0.00025 coulombs, and you multiply by 1 elementary charge over 1.6 times 10 to the negative 19 coulombs. That cancels. So let's see that divided by 1.6 times 10 to the negative 19. We get 1.56 times 10 to the 15 elementary charges. All right. The current through a wire is 4 amps. And we have a lot of electrons. So to get Q, first thing we have to do is find out how many electrons we have. So, or how much charge we have. So we have 2.5 times 10 to the 19 coulombs multiplied by 1 elementary excuse me, let's go back for a second. I wasn't very careful. That's elementary charges. Okay. So now things are a little bit different. We want coulombs, so coulombs go on top. So we have 1.6 times 10 to the negative 19 coulombs over 1 elementary charge. And if we multiply across, let's see what we get. We get 4 coulombs as our charge. How long does this take? Well, okay, let's see. Now I have my current, 4 amps. Charge, Q, is 4 coulombs. We're looking for T. So I equals Q over T. Putting the delta in front of Q really isn't that important. We have 4 amps equals 4 coulombs over T. T equals 1 second. All right. So I know this topic's a little bit new, it's a little bit abstract, but as we get working with current and circuits more and more, it'll become easier and easier. All right, so if you have any questions, let me know. Make sure you fill out the Google form, and hope you guys have a great day.